Right, good evening, guys. This is the second part two of today's online session. It's a repeat. Right, we're back. We're dealing with the RL circuit in here. We've determined in the previous session that this is your steady state. I of t is equal to B cos omega t plus C sin omega t, which I've labeled as equation 4. We then differentiate I of t, di dt, and gives you this, the next expression. Now we substitute in the Kirchhoff's voltage law equation number 2, which I've reproduced here, this 2 here. So it is L times di dt, so it's L times that expression. And that gives us equation 5 and Ri, right? So resistance times I, equation 4, and this leads to this expression here, which is equation 6. We'll then take both of this, right, equations 5 and 6, then we substitute that into this equation 2. And this is what we obtain. Right? This is your L di dt, and this one here is your Ri, and it is equal to your forcing function there, which is still Vm cos omega t. Right? We then factorize, so we take cos omega t, which is here, and also has factors here, the common factors, cos omega t, and the terms within the bracket are the factors that are multiplied with cos omega t. Right? And likewise for sine omega t, sine over here, we take the factors that multiply into it, factors that multiply into sine omega t in the bracket multiplied by sine omega t, and which is of course still equal to your forcing function Vm cos omega t. Right. Here, and there, and there. Now, having said that, we then observe the right-hand side. Right, the right-hand side has only got Vm cos omega t. Right, so that tells us that the bit with sine omega t of it must equal 0. Now, sine omega t cannot be 0, so only this factor in the brackets Rc minus omega Lb must equal 0. So that is represented here as equation 1. Likewise, Vm is multiplied with cos omega t. Cos omega t is here, so that bit here must be Vm. And that is reproduced down here as equation 2 in Roman numerals. So these are two simultaneous equations, and if we carry out the elimination, we should come up with a solution which is given over here. As your exercise and homework, do that and prove that you will get that solution. So I of t is equal to Vm divided by R squared plus omega L squared into R cos omega t plus omega L sine omega t. But we know that omega L over here is equal to XL, the inductive reactance. Substituting XL into the equation and breaking up a bit. So instead of having it here as a whole, we take the square root of it. But meanwhile, we also break it down, a part of it, the square root, to divide into R, and a portion of it, square root, to divide into XL. But you can see this is just an exercise in algebra. So if you multiply that square root times that square root, it gives you the full factor there. Likewise, this square root times this square root gives you the full number there. Now, the next step here, you will recall my earlier statement in session 1 on the importance of trig identities. Right? You can look at the form of this and relate it to this important trig identity. Right? Cos phi times cos omega t plus sin phi sin omega t equals cos omega t minus phi. Right? So all we do is look at cos omega t. There's cos omega t over here, cos omega t over there, sin omega t over here, sin omega t over there. So that tells us that this bit here must be cos phi. Likewise, that bit over there must be sin phi. Okay. Now immediately that should make us recall our favorite Greek uncle who lived a couple of thousand years before Christ was born, Pythagoras, who did a lot of work with right angle triangles. Okay. So given that is cos phi, that tells us that R must be if we draw a right angle triangle, R must be the adjacent, which is down here, and the denominator square root R squared plus XL squared must be the hypotenuse. Similarly, XL divided by its root of R squared plus XL squared is sin phi. Right, sin phi as opposite, right, over hypotenuse. So XL is there, and your hypotenuse is its square rooted factor, XR squared plus XL squared. So these, again, brings us closer to home on the important relationship between mathematics and electronics and electrical engineering. Maths is a very, very, very important tool. So once we got that, we can, knowing this abbreviation, abbreviation of this long expression, which is now all condensed to this, okay, we can simply say now that IT is equal to Vm over root of R squared plus XL squared, and the expression that is over here in this bracket has now been condensed in just cos omega t minus phi, which is that. So the beauty of maths, it has reduced that rather longish expression into a very comfortable and shortened form of IT. We can also find tan phi, because tan phi is just opposite over adjacent, XL over R, and phi is equal to the inverse tan of XL over R. Now, question you might ask, what is the importance of phi? Phi is called your phase angle. Right? Your phase angle. Now, it is important to know, and you also recall from your earlier work, that whenever we have a capacitive or an inductive circuit, there's always a difference in the phase between current and voltage. And the acronym that describes it very well is CVIL. Right? CVIL. Right? when you have a capacitor, current I leads voltage. Current leads voltage in a capacitive circuit. When you have L, you can see voltage comes before current. So voltage leads voltage leads current, right? Voltage. Sorry, I've made an error in here. Current, in the case of the capacitor, your current leads the voltage. In case of an inductor, sorry, it is voltage, right? It is voltage that leads current. Or we say current lags voltage. Right? So this is voltage is leading the current, right? And current is lagging by that angle phi. That now brings us to the end of session 2. Have a good evening, guys.